cents plus 320 times X, where X is the number of units produced and sold. Find the break-even point. Wouldn't that be where those two lines intersect? Okay, so this one is set up to solve it graphically. So put those in your calculator and find the intersection. Will you have to adjust your window? Most likely, yes. So let's do that really quick. So in Y1, I'm going to put 15.8x. And in Y2, I'm going to put 8,593, 20 cents. 320x. If you just push graph, you probably see one of the two lines, but you probably don't see them both. You probably see the 15.8 times x line, right? Those of you, well, we've been graphing lines by hand. 15.8x has a y-intercept of 0, right? So that one I'm going to see with a negative 10 to 10 window, but I'm not going to see the other one. And it is a really steep line, so I don't even see much of it. You can tell I'm going to have to go where my y values are taller. You probably noticed the y-intercept on the first line is 8,000, right? 8,500 or something. So my y value, my y max is going to have to be something bigger than that. Probably even bigger than 9,000, but at least bigger than, so you can see that line come across, see that one there come across, so I can now see it. I've kind of lost sight of my other line, right? It's kind of down here, so I'm probably going to need to change my X window to be bigger. We can play around with it if we need to. Did I make it big enough? No. In fact, I'm not really anywhere close, am I? So I'm going to need to get really a lot bigger on the X value and probably bigger on the Y as well. So I'm going to try 1,000. And I'm going to change this to 15,000. Looking better, isn't it? All right, I got it in there. Does everyone see how I played around with that until I found those values? Took me a minute, not too terribly long. Use your knowledge of lines to get them in view a little bit and then adjust the window accordingly. Then I'm going to go to second trace 5, enter, enter, enter. So I get 682 and I get 10,775 and 60 cents. So that's the break-even point, right? $682, 10,775 and 60 cents. I'll write it down. Why did I write it as 0.60 instead of 0.6? Because normally I just leave it as 0.6. It's money, isn't it? So if I sell 682 units, that's how much profit I'm going to make, and that's how much my cost is going to be. So my profit and cost will be the same. Or sorry, my revenue and my cost. Let's talk about profit. What is profit? It's how much money you actually bring in. It could be lost, but hopefully not. Hopefully we're making positive profit. But it's actually the amount of money I get subtracting out the cost. Right? If I'm running a business and I'm making t-shirts, sometimes you'll hear businesses give you their revenue number. That number is a worthless number. I can bring in $1 million in revenue. If it costs me $1,001 to make the shirts, I didn't make any money, right? So be careful with the word revenue. That's everything they bring in. Profit is a more telling number because it's revenue minus the cost. So this question says, how much profit will the company make if it produces and sells 500 units? So profit is always, so you'll want to write this minus cost. So profit is revenue minus cost. Does that make sense? It's how much you bring in minus how much the materials and running your factory and paying your employees, all those things cost. So my profit function would be 15.8x minus 8593.20 plus 320x. Are those parentheses necessary? Absolutely. Remember that algebra of functions section we did. You have to have parentheses when you subtract. So if I want the profit when I sell 500 units, what will I do? Plug in 500 and subtract, right? So I'm going to do profit at 500. So what did you get?
10,100.
So what is that value?
Negative 2,293.
2,000.
293.
Wait. That's not good. This is. Why is that not good?
Negative.
It's negative. So if I'm only selling 500 units, I'm not selling enough to be profitable. Does that make sense? So this company, if they're only going to sell 500 units, they're going to go under. Because that's not enough to be profitable. Now, just for fun, you might check out a bigger number. If you were to do 1,000 units, you'll notice they become profitable. In fact, after they sell 682, right? So 683, as soon as they're selling that much, they're becoming profitable. But they have to sell more than 682. How much profit will the company make if it produces 2,000 lamps, but it's only able to sell 1,800? So this is an interesting question. It makes 2,000 lamps, but it only sells 1,800 of them. So would you agree the cost here will be of 1,800? Or sorry, of 2,000? I made 2,000 lamps. So my profit this time will be R of 1,800 because I only sell 1,800, but I have to pay for all 2,000, right? So I'm going to do R of 1,800 minus C of 2,000. You get 13,446. So, am I still making money even though I'm not selling all my lamps? Because I'm produced enough to be profitable. Does everyone see that? You think this is realistic in a real company? Yeah, it costs so much to run your building, so it's going to take a while before you become profitable. But once you sell a lot of items, that's why Walmart is so successful. They don't make very much off of each item they sell, but they sell so many items, and they make just a small margin, it's enough to become a huge profit. How do we put that there? Get it out of here. Just a tiny bit. So some more problems. Sometimes they'll give us the equations, other times they won't. Sometimes we'll have to come up with the equation on our own. So, the sum of the 2011 revenue and twice the 2008 revenue for Mama Jones is, I don't know if it's Pete's Place or what it is. It's 2000. No, probably not pizza. Not making nuts. 2,144.9 million. The difference between 2011 and 2008 is 135.5 million. If the revenue is an increasing linear function, find the 2008 and the 2011 revenues. So this is a word problem through and through. We've got to do the setup and everything. So anytime you're reading a word problem, the first thing you're going to do is identify the things you don't know and how you can relate those together. So what do we not know that we want to know? What do I not know? What am I trying to find? Revenue in 2 different years, right? And are those the same number? No, in fact, definitely are not. So I'm going to let X equal the revenue in 2008. And Y equal the revenue in 2011. So the first thing you're going to do is identify what you don't know and give it a name. Give it a variable name so that we can set up an equation. Then you're going to set up an equation or a system of equations to solve. Well, what do I know about the 2008 and the 2011 revenue? You know about it. Okay, it's an increasing linear function. What else do we know? What's that first sentence say? The sum of the 2011 revenue and twice the 2008 revenue is 2,144.9 million. Right? Everyone agree? That sounds to me like an equation. You would agree with that. The sum of the 2011 revenue, what's the 2011 revenue? Y. Plus twice the 2008 revenue. What would you write that down as? What? Sum of Y plus 2X is equal to 2,144.9 million. You can leave this as 2,144.9 if you wish. Just note that X and Y will then be in millions, and that's okay if you want to leave it there, or you can write that out in millions if you would rather. Any questions about how let you do whatever you want. So, makes sense? You got 3 options. This one is set up pretty nicely for elimination. Does everyone see that? If I multiply the bottom one by -1 or something, or the top one by -1, or you could do 2. You got some options. Anyway, it's pretty easy, right? I'm going to go ahead and do -1. So I get 3x equals 2,144.9 minus 135.5 is 2009. Oh, yeah. So, any questions about that so far? 2009.4 divided by 3. Good. And what do we get for that? 0.8. What is that? What is X?
X.
The revenue in 2008. Right? Revenue in 2008. Now, if it's dollars, it's in millions, right? How would I find Y? Okay, plug this in for X is one of the 2 equations. Either one of the 2 equations, plug in for X and solve for Y. And Chris was picking the bottom equation, and so he's doing Y minus I did it before I changed the negatives, but you can do it either way. So add 135.5 and 669.8, and what do you get?
805.3.
Say that one more time.
805.3.
And that is the revenue in 2011. Why is that not the profit? Just a mental note, I just want to keep referring to that.
Because you gotta add the X and the Y, but the X is a percentage.
Say that louder. This is the revenue, right? This is her revenue in 2011. But it's not her profit. Because profit, you have to subtract off costs. So it's just revenue. Does that make sense? Not profit, because we don't know what profit is. Okay, so common ways to set up some word problem systems of equations. And that one we just have to read it and work through it. But some of them will be kind of the similar problem types. And so some common setups, and sometimes they'll give you a total, which they kind of did on this one. They'll say, these 2 things add to give you this. So A plus B equals the total. And sometimes they'll give you an amount of each. An amount of A plus an amount of B equals some total amount. Like I have 3 quarters and 2 dimes, right? So 3x plus 2y or something like that. Or they could do a percentage of A plus a percentage of B equals a total percentage. So those are some common setups. You might want to write those down. We're going to do a couple more problems. And I picked A and B. You could use X and Y. You could use M and N. I don't care what letters you use. You have choices. So of times I get these problems out of textbook problems and copy and paste them, and they turn out with some strange fonts. So Dan has $1,000 to invest. He chooses to invest it in a money market that pays 5%, and a mutual fund that is more risky but pays 8.3%. How much should he invest in each fund if he wants to minimize his risk, but receive at least a 7% return on his money? So what do I not know? That's the first thing I want to identify. Every time, identify that first. What do I not know that I want to know? How much I'm going to put in each account. So I have two separate accounts, and I have two separate piles of money. So I'm going to call it, I want to do A and B this time, or you stick with it? So X is the amount in the money market. Okay, so X is the amount in the money market, and it is very wise to label that. That way when you get to the end of your problem, you know what to answer. Right? You know what X found and you know what Y found. Y is the amount in the mutual fund. Okay, so I have two different quantities here. Probably going to need two different equations to solve this, right? Just like the last one. So, are there any equations that you can see that we can set up? Okay, so there's a percentage one in there, right? I'm going to skip that one first because there's actually an easier one than that. What do you know about X and Y together? What do they combine to give you? The total, right? I have $100,000 to invest. I'm going to invest it in these two places. So my first equation is X plus Y is $100,000. So I have $100,000 to invest. The second equation is tougher to write. But for whatever X I invest in the money market pays 5%, right? How do you write 5% when you're doing that? 0.05, because you know why? Percent means per 100, so 5 out of 100 is 0.05. So whatever I put in X is going to get 5% interest, right? Whatever I put in Y is going to get 8.3% interest. And what is that going to add to the total? What do we want to get? How much? 7% of what? 7% of the money back, right? So I want to get 7% of the $100,000. I'm going to gain that much money. Does that make sense? So if I put in whatever I put in X, I'm going to get 5%. Whatever I put in Y, I'm going to get 8.3%. But I want a total of 7% of my money. That's how you'll write an equation for interest. Because I did the last one with elimination, you totally could do this one with elimination. Do y'all want to see a calculator one? And this one's a good calculator one to do because the numbers are going to be a little yucky. Why are the numbers going to be a little yucky? Decimals, right? So I'm going to have to kind of work through that and so just so you can see one in the calculator. We could have done the last one in the calculator too. This top equation would be Y equals negative X plus 100,000.
Staff, please excuse the interruption. I need to see the following students in room A3 at this time. Riley Bagwell, George Bice, Camden Hall, Kelly Holiday, David Hood, Johnson, Rachel Martin, Tyler Martin, Michael Mickelson, Samantha Morris, Nicole Niblett, Michael Norman, Seth Oliver, Olivia Rice, Austin Rosas, Ethan Ryan, Haley Sanabria, David Seavey, Jenna Slater, Eli Smith, Dylan Boda, Savannah Wesley, David Wycott, and Michaela Wilson in room A3. Thank you.
Okay. So, before I get before I get y by itself on the next equation, I'm going to go ahead and multiply. I'm going to go ahead and multiply 0.07 times 100,000 so that I don't have to work with that messy number there. What is 0.07 times 100,000? I'm going to do that. 7,000. So that'll just make my life a little easier that that's supposed to work. I want to get y by itself, so I'm going to subtract the 0.05x over. Because you're about to use your calculator, can you leave this as messy as you want to leave it? So you could leave it as negative 0.05x plus 7,000 all over 0.083 if you would like. Your calculator can graph all of that for you as long as you get y by itself. So I'm going to put both of those in my y equals. Again, elimination would work great. You don't have to use the calculator. Some of you will prefer elimination because you don't have to worry about setting your window. I just want you to know that you have options. And what was that top equation?
Negative x plus
X plus 100,000. Make sure you get the right amount of zeros in. Would you agree that my y max probably needs to be something like 100,000? Since I have that y-intercept of 100,000? Okay, so I made my y max 100,000, which seems to work okay. It looks like they might cross, but it looks like quite a bit farther than what I have here. Remember, x and y are numbers that add to be 100,000, so they're going to need to be big numbers, right? So I'm going to need to go change my x max. I'm just going to go ahead and go to 100,000. Because x couldn't be bigger than that because I only have $100,000 to invest, correct? Oh, did I only make it 10,000? Try 100,000. See, watch those zeros. Do we see the intersection? Go to second trace 5. And you get 39,393.94 and 60,606 and 6 cents. So everyone see how that works? That is the value I would put in each account. So in the money market account, I would put the 39,000. In the mutual fund account, I would put the 60,000. So if I were investing, that's how I would allot those two values. Write those values down. So I'm probably just gonna go on to the next slide. So 39,393 in the money market and 60,606 and 6 cents in the mutual fund. How did I know which one was which? How did I know the X was the money market and the Y was the mutual fund? That's how I set it up. I labeled it that way to begin with. And I think I answered all the questions. Yep. How much should he invest in each fund? Got it. Okay, I think this one's the last problem of the day. A pharmacist wants to mix two solutions. So this is something, if you go on to take more chemistry, so if you're a science person, if you go on to take more chemistry or biology, you will have to do this in a lab someday. I remember having to do it in my biology lab at college, having to figure out what to put in where to get the right concentration of a solution. So this says it's a pharmacist, but it's something you will probably have to do. I remember having to do this exact math in my biology class in college. A pharmacist wants to mix two solutions to obtain 500 cc's of a solution that has an 8% concentration of medicine. If one solution has 10% and another has 5%, how much of each should they mix together? So again, common problem in biology. Have y'all ever seen in your biology class, which I don't know how much they do here, they'll have different concentrations of alcohol, but for a certain experiment you'll want a combination of the two, and so you'll use both. That's where this would come into play. So, what are my two things I don't know? That's always my first question. How much of each, right? So I'm going to let X be the amount of my 5% concentrated solution.
Please excuse the interruption. Please see the following students in room A3 at this time. Andrew Bink, Hannah Beck, Taylor Brasher, Zachary Birch, Dakota Coles, Brecken Cook, Stephanie Downs, Stasha Bott, Donald Falkenberry, Maria Gioli, Faith Hobbs, Johnny Howard, Lacey Markworth, Taylor Martin, Faye Miller, Eric Moran, Lily Pugh, Davin Roses, Isabel Rossetti, Henry Strozier, Brianna Wagner, Jimmy Watterson, T.J. Whitmire, George Bias, Kaylee Holliday, Dakota Johnson, Olivia Rice, Ethan Rye, and Jimmy Slater in room A3. Thank you.
Okay, any questions so far? Why I would pick those two unknowns? What do I know about X plus Y? Notice I'm going to use that a lot. Something equals 8. What about just X plus Y? How much solution am I making? 500 cc's. That's an amount. So 500. So X plus Y equals 500. Does everyone agree? The two pieces, two parts, need to add up to 500. But, Chris was saying, we want an 8% solution, right? So, if it's alcohol, what does it say what it is? It's medicine. If you want a certain percentage of the medicine in that solution, so part of it's probably water, maybe it's for a kid, so it's got some bubblegum flavoring in it, who knows what it's got it, right? So, the solution is more than just medicine. But we want there to be an 8% concentration of that medicine in the solution. So that's our game plan. Well, the X has a 5% concentration. The Y has a 10% concentration. I want that to add up to be 8% of the total solution. So 8% of what? 8% of 500. Does this feel like it's a little bit like the money market problem? It's not. It's a totally different field of science. For a business science, totally different fields. Set up the problem is identical. You have two things adding up to the total, and then a percentage of one plus a percentage of another adding up to the percentage of the total. So that's a common setup of some of these problems. Any questions so far? Are y'all okay if I don't solve this out? Get a Y by Excel, put it in the calculator, or do something like that, or do substitution, or do elimination. I'm going to go ahead and do this homework. I will that it's using.